I'm going to talk to you today about Pact and how it can transform your integration testing process. Just yell if I'm too quiet, by the way. I've not ever been accused of being too quiet, but if it's going to happen. Alright, a few years ago I watched a talk by a guy called J.B. Rainsberger that opened with the following provocative words. Integrated tests are a scam, a self-replicating virus that threatens the very health of your code base, your sanity, and I'm not exaggerating when I say your life. So why are integrated tests so hated? Well, integrated tests tend to be slow. So we run them less often, they don't give us as good feedback on a design. Because you end up with a many-to-many relationship between your lines of code and your tests, when a test breaks, it's hard to say exactly which line of code has caused it to break. And because each line of your code is covered by multiple tests, if one of your tests breaks, it's likely that a whole lot of other tests are going to break with it. So you end up with a page of noise that's not really productive. The other really bad thing about integrated tests is if you use integrated tests to check the basic correctness of your code, the number of tests that you need actually scales combinatorially with the number of classes or components you're using. So as an example, if you have three classes, each with 4 methods, then the number of code paths is actually 64. Nobody wants to write 64 tests. So given that integrated tests causes so much pain, why do we continue to use them? It's because we've all had that day where we've handed over a shiny new feature to our tester, and we're feeling pretty smug because we've used TDD, and we know we have 100% unit test coverage on our code. And the tester brings up the new page and gets a big fat 500 error. And we look at our tester as if to say, well, my tests are green, this is your fault. What have you done wrong? But we humour them and we look in the logs, and we discover that find by ID method is raising an exception. And we think, well, I know I had a test case for when there was no record found. But then you go into that test case and you realise that you'd actually stubbed find by ID to return nil when there was no record found. And in actual life, it raises an exception. So then you think to yourself, I would have caught this if I'd written an integrated test. So now you have a dilemma. If you want to find all your errors, you think, oh, I'll introduce integrated tests. But if you do that, you've included these slow, brittle, heavy tests into your code base that are going to make your life more painful. So the question now is there another way to find our errors apart from integrated tests? And luckily for my talk, or it would be really, really short, the answer is there is another way, and it's called achieving test symmetry. So what is test symmetry? Test symmetry is a way of verifying that the assumptions we make when we stub something are actually true. And it works like this. In our code, A makes a call to B. In our test for A, we use a mock B because mocks help us avoid that combinatorial complexity problem. Then we test that A makes the calls that we think it should to B. Then we check that A handles the responses we expect back from B. Now, there's nothing new here. This is what we do all the time. These are what is called the collaboration tests. But this diagram kind of looks half finished. What we so often miss are the tests on the other side of this diagram that are called the contract tests. Here, when we tested A, we used a mock B. When we test B, we kind of want to have a mock A. We want a test that runs the calls that we expect A to make against B, and to check that the responses that come back are actually what we think they should be. the key to this is, if we could achieve perfect test symmetry, we had matching contract tests for all our collaboration tests, then we wouldn't need these messy integrated tests. And we live in a land of symmetrical sunshine and rainbows and unicorns. So, why do we not live in this land of symmetrical rainbows and sunshine and unicorns already? Well, it's because achieving test symmetry is hard because there's a lack of tooling around this. It relies on the internal vigilance of the developer, which, just like Rails, does not scale. But finally I got a laugh at that one. The number of times I've done that one has just been blank.
There's probably a lot of .NET developers.
I tried it at Seek and nobody laughed. Anyway. So I posed this question to my workmates at DS. Like, has anybody else heard of a tool that could help us achieve test symmetry? And there was a lot of silence. And then finally my workmate Ron put up his hand and said, well, actually out at realestate.com.au, where he'd been working, they were trialing a new tool that was based on a real estate. It is unsurprising then that they have their fair share of the monolithic software, the tightly coupled monolithic software, where you're afraid to change one thing over here because you don't know what the unexpected effects are going to be in completely, seemingly unrelated areas. So to avoid this anti-pattern, REA has consciously chosen to write small, single-purpose, tightly focused services, microservices. So the good thing about microservices is they take your sprawling code base and they make it into small, easy to understand chunks that are easy to rewrite, reuse, easy to throw out. That's the best part. But on the downside, they increase the number of integration points. And with an increase of integration points, there's also an increase of system integration testing. And if integrated tests within your code base is bad enough, then system integration tests are the worst. They're even slower, they're even easier to break, they have all sorts of environmental issues, they're even harder to fix, and they scale really badly. And on top of this, there's also lots of setup. They're generally flaky due to timing issues, and you generally have to set up a whole extra set of infrastructure to run the tests on. So now we're kind of back to the same problems we were talking about at the start of this talk. And now you're probably wondering what Ron's magic solution was. This is the extent of my photoshopping skills. I'm a developer, not a designer. So, Pact uses consumer-driven contracts. Now, when we write a consumer-provider kind of architecture, often we start with our provider. And we look at our data source and we go, what's the easiest way to get the data out of my data source into a response? And then we go and we write our consumer and we make sure that it makes the right requests to the provider to get that data. Consumer-driven contracts turns that around, and we start with the consumer and we say, well, what format makes sense for me to consume this data in? How do I want to get to it? And then we make sure that the provider actually complies with the way the consumer wants to see the world. So Pact uses consumer-driven contracts and it automatically enforces test symmetry. And here's how that works. This diagram probably looks familiar. We have service A and service B. But in the consumer provider world, we call this the consumer and the provider. So our consumer might be our JavaScript front end or any other service. Our provider could be a JSON API or anything else you like. So when we're testing our consumer, we use a mock provider. This mock provider is provided by the Pacts library. Then we check that the consumer makes the requests that we think it should to the provider, and we check that the consumer can handle all the responses we expect back from the provider. Now Now remember I said that the hard part of achieving test symmetry was the lack of tool support. This is how Pact helps you achieve that test symmetry. While we are running our consumer tests, the mock server records the requests and the expected responses and puts them into what we call a Pact file. This is just a JSON file. You can open it up, you can inspect it, whatever you like. Then we take that Pact file, we go over into the provider project, and we use the Pact file to replay the requests against the provider and then check that the responses that come back match the responses that the consumer expected. And if the responses match, then we know that when we put them together in real life, they're actually going to talk in a proper conversation that makes sense and works, all without having to run these brittle, slow integration tests. So the problems we had with integrated tests and test symmetry are solved by Pact. Not only do we get the automatically enforced test symmetry, we get tests that are fast, there's very low setup, they're reliable because you're not dealing with network issues or latency or capybara not rendering your page properly. They're much easier to debug. You can run these in a standalone CI build, so you don't need extra infrastructure. And if you write your tests cleverly, you can actually get them to scale linearly with your functionality, not combinatorially. And because you're starting with a real-world use case for your API, you get a really usable API because it's driven by the requirements of your consumer. Now, this is my favorite part. It's the code example. I know Ruby is not everybody's first language, but hopefully this is readable enough. Now, I've been told that I need to put a diagram here to show you what part of the test symmetry we're achieving, and I didn't get time to do that, so I'm going to draw it on the board. So, provider. Okay. So here, I'm writing a zoo app as my consumer, and it's going to have a pact with the animal service, who's our provider. And I'm going to tell it to run on port 1234. Now, that's somewhere over here. We haven't run anything yet, we're just setting up our mock server. Alright, first, every test has three parts. Act, arrange, and assert. So this is our, that's the wrong order, arrange, act, assert. This is our arrange part. So we're setting up our expectations on our mock service so it will behave the way that we think the real service is actually going to behave. So we're over in our consumer world. We're actually sending a little message to this mock server here saying, hey, this is the request that I expect to come through. So our animal service, given there is an alligator named Mary, this is what we call a provider state, and I'll explain why we need that in a second. Upon receiving a request for an alligator, we expect a get method with a path, the alligator's Mary. We want it to expect an application JSON response, and we expect a 200 response with a nice little document named Mary. So at this point, we've just set up our expectations. Next, we need to actually do the act part. So I'm not going to show you the code here, but assume we have a class called the animal service client, and its responsibility is to make calls to our animal service. I'm going to tell it to find alligator by name. It's going to actually make that HTTP request that we described before. And then it's going to assert that the thing that comes back has been turned into a domain model alligator with the name Mary. So when we run this, we're doing this part here. So our client will execute an HTTP request, and then Our mock server will respond with that response that we set up, and then our client will deserialize that JSON document and turn it into an alligator model for us. Now, while we were running that test, our mock service was creating this pact for us. Got our provider name, our consumer name, and then an array of the interactions. So there's our description, a request for an alligator, our provider state, there is an alligator named Mary, and the request and response details. So up until that stage, we've only done this part of the diagram. Now we're going to do the other part of the diagram. So this is the reverse of that configuration we started with. We're telling our animal service, hey, you're the animal service and you need to honor the pacts that the zoo app has written for you. And we tell it where to get the pact from. This could be any URL. Then we need to set up our test data. Remember back in our consumer, we assumed that there would be an alligator named Mary. Provider states gives us hooks to set up the right data on the provider before the request is replayed, so that the response will actually look like the response we expected. So here, we would put an alligator named Mary into our database. Now, then we run our Pact verify task, and that will take all the interactions in our Pact, play each request back against our animal service provider, look at the response that comes back, compare it with the expected, and if they all match, which of course they're never going to do it the first time, then they'll fail. They'll fail a lot. They'll fail for a very long time until it's all complete, and then you'll get this screen here. I should put in a failing screen, seeing as that's what people see most often. So we have a dynamically created test harness. We can see that there's our description, a request for an alligator, there's our provider state, given there was an alligator named Mary, and it's asserted that the response that came back had a 200 status, it had the right body, and it had the right headers. So now we know that our zoo app and our animal service will communicate properly in real life. Just test my next slide. Right, I put in a new bit here because you guys are special. So when you're writing microservices, the first few are pretty easy to keep all that information in your head. You're probably writing them, you're probably dealing with them all the time. That's going to work for a little amount of time, and then like with your REA, 18 months later you have 60 microservices, and there's no longer a point where you can actually understand what everything, or what all of them do. You probably don't know what the half of them actually exist because they were probably written by other teams. You don't know what's actually out there. Is there something you can reuse? Has somebody already written the thing that you think you need to write? The little bit of a dirty secret of microservices is that they don't necessarily reduce complexity. They actually take the complexity out of the code base. They reduce it within the code base, but they actually increase the complexity between the code bases. So we need tools to help us manage that complexity. Otherwise, we're just going to make life harder for ourselves, and we're just going to say, oh, screw this microservice thing, let's just go back to writing monoliths. So there's a tool that comes along with Pact, which can help you manage this complexity, and it's called the Pact Broker. Now essentially, the main purpose of the Pact Broker is it's a repository for Pacts. It's a way to share Pacts between the consumer and the provider. So the consumer build will generate the Pact, it will publish that Pact to the Pact Broker, and then the provider will know the URL that it needs to call to get the latest Pact between itself and its consumer. But the Pact Broker also comes with some very cool features. One of them is auto-generated documentation. The Pact JSON is kind of, it's documentation in a way, but really only the devs want to troll through our JSON files trying to work out what's going on. But we can turn that into a nice HTML document that has all our requests listed at the top and then all the full interactions listed underneath. Even a VA could read that. Our testers actually read this stuff and they understood it. And the other thing, this is actually my favorite thing, is that I had to, redact the service names. This is actually a real live diagram from REA, but I've updated the names just in case they were confidential. The other thing,
their names are practically like that anyway.
I've written a piece of code that stops anybody calling a service a service. But they still managed to do it. Anyway, auto-generated network diagram, so you can see what talks to what, and then go over and click on the link and see the pact for to understand the conversation between the two services. The other thing is, if you want to decouple the release cycles of your consumer and your provider, there's this funky little testing thing you'll need to do, which I call the Pact matrix. So essentially you want to know that if you deploy the head version of your provider, you want to know if it's compatible with the prod version of your consumer. And the other way around, you want to know that I've deployed my consumer now, is it compatible with the prod version of the provider? So your standard Pact test will naturally be testing this and this. You'll have the latest Pact against the latest provider code base. But what you want to be able to do is test your head consumer against your prod provider and your head provider against your prod consumer. So you can do this with Pact quite easily by tagging the prod Pact. So now in your provider, you give it a URL for the latest Pact, but you also give it the URL for the prod Pact. So you will know whether or not your provider is actually backwards compatible. Because the Pacts are written in JSON, a Pact library could be implemented in any language. And we have in this room 2 people from the .NET Pact implementation team, thank you very much, and one of the future Python implementation team, who I'm looking at to make feel guilty until he writes it. Ruby is the first language that was written, and it's also the most feature complete. The JVM version is going pretty well. We've got Java and Scala and even some Clojure wrappers around it. There's a, is that the right word? Anyway, we've got JavaScript DSL that makes use of the Ruby mock server, but we're hoping to write an actual JavaScript mock server, so you don't need to have any Ruby dependencies very soon. Because the way Pact works, you could validate against any running provider, regardless of your language. So I've been working on a Pact specification to make sure that all the implementations are consistent, because what we really need is that the matching is exactly the same in each library. So you can write your consumers and providers in whatever language you like and know that the behavior will be consistent. There's another gem as well called Shikenki, which is written by one of Pact's original authors that has some slightly different features, but it's based on the same concept. So this is what I call the Dr. Phil question. How is it working for you? So before Pact, each service had its own pre-production environment or certification environment into which was deployed all the production versions of the other microservices that that service talked to. So if you do the math in your head, the number of instances you actually needed was n squared, because each service would have a complete copy of all the other services in its context. Didn't scale really well, and meant you had to maintain a different set of integration tests for each context as well, because if you're putting a new feature into one thing, yeah, it is complicated. It didn't work. It was painful. So with Pact, we have, that says 50 plus, but I think it's actually 60 plus microservices using Pact. Now if the standalone CI build is green, we're pretty confident to deploy. It's not just REA that's using Pact as well. Multiple DS and ThoughtWorks clients have been using it, Seek's using it, Aconex, Huru, there's a bigger list and I can't remember right now. So in summary, your integrated test will touch many points along your consumer provider and give it multiple chances of failure, more chances of failure. By breaking your tests down into smaller chunks, you make them more reliable and faster running. So, this is the sell slide. Pact allows you to combine the advantages of integrated tests and test symmetry while mitigating the shortcomings of both methods. Allows you to modify components with agility because it gives you a really quick feedback cycle if you're going to break either your consumer or your provider. You know before you commit, essentially, because you're running these tests without having to make calls to actually running services. It gives you the confidence that all the services in your system will work together. And the best part is it allows you to throw out your integration tests. Alright, Pact makes your microservices play nicely together with consumer-driven contracts. My name is Beth. Those are the contact details. And I would love to take any questions you have if you have time.